Hello, this is the AP lab review. So some of the lab questions that you might potentially see on the AP test, they could be procedural, and that just means knowing some, the procedures, the steps in a lab for some sort of lab process, like doing a titration or doing a dilution. But procedural just means what steps would you take in a lab to do something. Could be a question about lab equipment, as in what lab equipment would be needed for a certain process. So you just want to be familiar with the different pieces of lab equipment that we've used and what the functions of those pieces of lab equipment are. You could evaluate or explain data from a lab. So just given the information that was obtained in the lab, what can you tell? What kind of calculations can you do from that? And then finally, it could be error analysis. So they could describe some sort of mistake or any type of error that took place in the lab. And then you have to be able to determine what kind of effect that would have on the final result, as in, would it increase your final answer? Would it decrease it? Would it have no effect? And be able to explain that. So just being able to take a certain error that takes place in the lab and determine what effect it would have on your final result. All right, now I have a few slides of some of the different required labs that we have to do that you might be questioned about on the AP test. And then on each of these slides, there's some links to either the lab sheet that we did or a video or some other information that might help. This slideshow is shared for you in the final review folder, okay? So that you can click on some of those links if you need to. But anyway, the first required lab is spectroscopy. And then we did this as a PhET simulator. And in spectroscopy, you wanted to be able to determine the concentration of a solute in solution based on the color of the solution. And it's referring to a Beer's Law lab. So with Beer's Law, this is the snapshot of the simulation that we did. You shine a light through a colored solution. The container for this thing that's in the colored solution is called a cuvette. So you shine light through this colored solution, and then you have some sort of detector on the other side to figure out how much light goes through. So there's a certain intensity of light going in, so the original, and there's a certain intensity of light going out, and then the amount of light that gets absorbed, that's called the absorbance. And that goes along with this equation right here, which is on your green sheet. It's on your equation sheet. Capital A is absorbance, a small a, or sometimes it's you see it as this epsilon instead of A. That is molar absorptivity. B is a path length, and the path length is just the width of this cuvette, usually measured in centimeters. And C is concentration. And usually what happens is you graph this out. You graph out absorbance versus concentration, and you get a straight line. And you can measure out that slope, and the slope is going to be equal to this molar absorptivity times the path length. And then if you know the path length, you can figure out what molar absorptivity is, and that's usually the whole point of this lab. Okay, the next one is gravimetric analysis of a precipitate. And with this lab, you want to find the identity of an unknown compound using mass data. So the term gravimetric analysis, that just means that you're finding the weight of something and then doing some calculations. That's all that is. The lab that we did was the hydrate lab, where we got a yellow precipitate, we filtered it, we dried it, and then we did some calculations with that. So there's a link to that lab sheet right here. This is another type of gravimetric analysis lab that sometimes comes up in AP questions. We did some FRQs that were similar to this lab situation right here. But with gravimetric analysis, I put some steps over here, but the ones that always show up that you really need to know about is you have to have precipitation. So precipitate is you mix a couple solutions together and a solid forms, and the solid comes out of solution. It's a precipitate. And then you filter it, and then usually wash what's been filtered just to clean it off a little bit. Rinse it usually with distilled water. And then you dry it. The most common method is what we use, just a drying oven. And then you weigh it. And then you usually have to subtract out the mass of the filter paper. And then you can do whatever calculations that you need to do. So those steps are always in every type of gravimetric analysis lab. Okay, the next type of lab is a stoichiometry lab. And this is a link to the stoichiometry lab that we did. And with this, you determine the amount of dissolved particles present in a solution. And this could be any type of lab that you can convert to moles and do stoichiometry calculations would qualify as a stoichiometry lab. So it could be gas stoichiometry, where you're using the ideal gas law. It could be solution stoichiometry, where you're using molarity equal to moles per liter of solution to convert it to moles. It could just be mass, where you're making mass conversions to convert to moles. But anything where you're converting to moles and then making calculations from that and doing stoichiometry counts as one of these labs. All right, the next type of lab that you want to know about is a solubility lab. And then with this, we determine the amount of dissolved ions in solutions, and it usually involves some sort of precipitation. And what the lab that we did for this was determination of KSP lab. It was one of the last labs that we did, or towards the end at least. And then you do a serial dilution, and then you see at what point does precipitation start, and then you can determine KSP values. But that's one type of lab. All right, next is redox titration. So with this, you measure the amount of acid contained in the solution. So we did a couple of redox, or a couple of titration labs. The redox titration lab that we did was the bleach lab, and this was early first semester. So with redox titrations, or any titration, there's a couple different processes that you want to know about. First of all, titration prep. And then we did a couple of these, but just to refresh your memory, you want to start with rinsing the burette, and I showed a picture of the burette over here. So you rinse, the first step would be you rinse a burette with distilled water, and the second step would be you rinse the burette with a small amount of the titrant. That's a solution that's going to go into it. It's called the titrant. The third step is after you drain out all those rinsings, you fill the burette with the titrant. And the fourth step would be you remove the air bubble by quickly turning on and off the stopper. And then you're ready to proceed with the titration. So with any type of titration, that's kind of the beginning part of it right there. And then you always you measure a starting volume, or the initial volume, and you measure the final volume of the titrant. And then you subtract those two to determine how much of the titrant was added to the analyte. And then you can do your calculations from that. All right, then you also want to know how to do dilutions. And a dilution starts with an equation. This M1 B1 equals M2 B2. And the one side here, this is molarity times volume. This is for the more concentrated solution. And then M2V2 is molarity and volume. This is for the dilute solution. And usually what happens is we have some sort of, it's called a stock solution, which is more concentrated. That's what it's shipped in. We want to figure out how much of that more concentrated stock solution, do we need to make some volume of dilute solution? So it's usually V1 that you're looking for in this calculation. And then for the process, the piece of lab equipment that you want to use is called a volumetric flask. And the volumetric flask looks like this. It's like a round bottom flask like this. It's got a longer skinny neck, and it has one line up here on the neck. And it measures just that certain volume right there. So if this is, say, like a 500 milliliter volumetric flask, when the solution gets to this line right here, you know you have 500 milliliters. That's the only volume that it measures. But the process is you want to put some distilled water just part way up the bottom portion of the flask. And then you take however much of the concentrated solution you need, so whatever V1 is, and then you add that to the distilled water that's already in here, so it's going to go up a little bit. And then you add water until it goes all the way up to this line right here, and then it's diluted to the final molarity. So that's the process right there. Add a little bit of water, distilled water, add some of the concentrated solution, and then dilute up to the line for the required volume that you need. All right, the next one is a reaction rate lab. And with this, you're manipulating variables to see how they affect chemical reaction rates. And then here's a link to the rate of reaction lab that we did. And it's usually just changing the different factors that affect a reaction rate, timing it to see how long that goes, and then see how that affects the rate. The next type of labs is energy labs, and with this we want to determine change in energy, it's usually heat energy, in various chemical reactions. So these are the calorimeter labs that we did. So we use this double coffee cup calorimeter, and then you can do different processes in that calorimeter, and you can mix up the water, and then you measure then you have a thermometer to measure the temperature change. And then you can determine if it's going to be endothermic or exothermic. So the water that's in the calorimeter is usually just considered the surroundings for this lab. So if the temperature of the water in the calorimeter goes up, that means it's an exothermic system, that's exothermic reaction that's taking place in the calorimeter. And if the temperature of the water in the calorimeter goes down, then you know it's endothermic. The next one is an equilibrium lab, and that's where we're trying to maximize yield in chemical reactions. So really it's just knowing if you put stress on a system, which way will the system change to get back to equilibrium, as in which way is it going to shift. And you just want to know, this is the link to the Le Chatelier's lab that we did, and you just want to know which way the system will shift to get to equilibrium. So these are labs that we didn't have to do this year. Those are a couple other labs that we did, but they're not required labs for AP. We did molar volume of gas. That was working with the ideal gas law, and this was the Lewis dot structure lab. Okay, and here's your assignment. So one, you want to describe how you would prepare a burette for a titration and make sure you include at least 4 steps. 2, you want to list 3 observations that would indicate that a chemical reaction occurred, so 3 indicators of a chemical reaction. And then 3, describe how to properly dilute a solution, including the lab equipment used. And this is for 5 lab points. And then just you can either type up a Google Doc and share it with me, or you can just email answers. And that's it. Have a good day. Bye.